Hello YouTube friends, this is Tom, K2BEW. I am back in the shack with the K2, which you can see is powered up in front of you. I have the light on, I will dim it when I'm ready to do it, but you see my scope is on in the background. I'm going to talk a little bit about where I'm at in the build before I do this next alignment that I thought I'd videotape. You can see that we are fully populated. Everything is put together now. I have put in the last thing, and I did a little cell phone video on it, and I ended up deleting it because it came out terrible, but I'll explain it, what was on it. This here is where your power output is. This is the transmit chain going to the antenna, of course. And these two screws back here, there's one up here and one down here, hold your output transistors. You have a matched pair of transistors for the output on the K2. Underneath, and I'm going to have to flip this around, you will see 4 screws there in the middle of that back panel. That entire back panel is the heatsink, and the 2 nuts on the outside go right through the transistors. There's holes in them, and it holds the transistors against the metal as the heatsink. The 2 black screws inside simply go to a standoff, which just clamp everything down tight, so you're tight against your heatsink, ensuring you have good contact. Now, I didn't show all this, but I had done a phone video that I lost. Well, I deleted it. It came out terrible. On top of the transistors, you put 2 pads. Those pads are insulating pads that go between the transistor and the heatsink, because you cannot have the metal to metal touching, because it has to be not to ground. So when you put those pads in, when I initially put this together and I put those pads in, you then check for a short between the collector on both of those transmitting output transistors to ground, and they were showing short. I went back and forth. I shaved a little bit out of the holes. I thought the screw was touching. I determined it finally that it was not. And I found out from the reflector what often happens, and I'm sure what did happen to me, is you get little microscopic aluminum chips in there that get embedded in the insulation pad, and when you clamp down the screws, they make contact and they short to ground. So I ordered new pads from Elecraft. I have put the pads in, and my short to ground has disappeared. So I now have the transistors properly installed in there with no short to ground. I was going to do a video on it, like I said, to show people what was happening, but if you get to this point in the build and you run into a short to ground, I would recommend not powering the radio up until you fix it. And I did not power it up until it was fixed. You order the parts through the Elecraft website. You have to actually request the price for the part through their help section, but they're inexpensive. I ordered 4. You only need 2. I kept 2 on backup, and we're good to go. Okay, so now the next part of the build is you power it up and you check the transmit, as you can imagine. I have to confess, I did a little bit of this offline already, not thinking about it because I was kind of excited to see if it worked, and then I'm like, well, I should make a video of this, so I'm going to go ahead and do that. So I'm going to turn down the light. So what's happening here is we're in the 40 meter band of 4100. This is all in the book. You turn your power to 2 watts. So we hit power. We just turn the knob, actually. Let me show you. And I'm blocking it with my hand. So you can see that's your power output in watts. So I have 2 watts, okay? Now I have my antenna output to my dummy load over there, and across the dummy load I have 2, and I purposely did this when I made this dummy load. I have 2 outputs on it, negative and positive. I have my oscilloscope going across the oh, it fell out. I'll put the probe back in. I have the probe on the positive and I have the ground on the negative, and that's going over to the scope so we can peak it recommends, there is a watt meter in here which you can use to peak it, but it recommends an oscilloscope or a watt meter. I don't have a digital watt meter, so we're using the scope. So let me just get my scope probe back in. So the scope probe is across. Now there's a tune button. I should back up a little. There's a tune button here. You hold down the tune button. It's yellow. You hold it down till it tunes. As soon as it's in tune, it starts putting out approximately 2 watts. And you peak your output with L1 and L2, which are in the back of the radio. They're just the 2 little inductors back here, 1 and 2. You peak your output. That's all we're doing. You can peak it off here, just looking at the number, or peak it off a scope, which is more accurate. And that's what I am doing. And I will show you. Now I've already peaked them, but I'll make it move so you can see. It wouldn't hurt to double check it anyway. It's always good to go back and re-peak. So let me turn that off. So this is 5 volts per division. I just simply put it at a setting where this would stay online. I tried AC, and it's too warbled. The line is really hard to read. In DC, I'm simply moving the line up or down for power up and power down. Now you notice my scope trace does not go all the way across. This scope needs to be recapped. It has to do with the capacitors in the horizontal and vertical trace. So the trace works, the scope works, but it needs new capacitors. That's why this is screwed up. Instead of having a perfectly straight line. It's straight, but it's tailed off at the ends. And it's out of focus on camera. Let me try, and forgive me for doing this real quick. I'm gonna see if I can bring up, I can't bring it up. I'm gonna have to pause this and try to do my focusing. I'll be right back. Okay, we're back. What I actually had to do is turn down the intensity on the scope. It was washing out on the camera. So now you can see the line on the scope and how it tails off at the end, like I said. We're set to 71. I'm going to put it in the tune position, and immediately you're going to see the line on the scope pop up. Well, it didn't pop up. Am I off? Yeah, it was my probe. So there it is. The probe was not touching the metal. It's up. So I'm going to turn it off. Okay. Let me just tighten up this probe. I don't want the probe to slip while I'm doing this. I have it screwed under a nut. The tip of the probe. Okay, let me try again. Make sure we're getting the output on the scope. There we go. So when that goes up, I'm going to peak it for maximum output. And what you're seeing on this on the screen on the Elecraft is the power. Okay, and let's make sure we're still at 2 watts exactly. 2 watts output. And the other thing you watch for when you start doing this is smoke or anything. If your transistors are shorted or anything, I haven't had none of that. So it is working. It is putting out power. So here we go. That's going. It's in the tune position. Now watch as I turn that. You can see it going up and down a little. See it moving, and I'm going to peak it. Okay, let's turn it off. You don't want to leave it on that too long. Okay, we're going to do L2. Next, L2. That was L1. Where's the slot? Okay, L1. We peak that line up. Max. And our output is 3.2. That's good. That's better than I had before. I had 3.1. 3.3 even. So now it's peaked up. So that's the 40 meter transmit is peaked up to the tune position. All right, we're going to now I've done that. I did that previous to this video, but now we're going to move on to where you put more power through it. Okay. Make sure the higher graph is set for wait a minute. If necessary, repeat. Okay, make sure the bar graph is set for dot mode using the graph menu entry key. Got to turn the light on. We want to go to menu, bar graph. It's set to dot. is set to dot. Okay, that's fine. Go back to display. Set the power to 5 watts. Okay, we're going to set that to 5 watts. All right. Tap display to enter voltage current display. When this is selected, you can use the tune to check your voltage and current and transmit mode. Enter tune mode and note the change in the voltage in the current drain. At 5 watts, it is typically 1.3 to 1.6 amps. If the current reading is higher than this, or if the voltage drops more than 1 volt, you may have a problem in the transmitter load or power supply. Okay, that's easy enough. So you hit display. So this is your voltage. It's 13.1 volts. We're at 0.22, which is 220 milliamps of output. That's on receive, and that's normal. So we're going to hit tune, and we want to watch what that output power goes up to. So we're 12.6 volts and 1.56, 1.58. Okay. You should have 1.3 to 1.6. That was good, and we should have a good voltage, which we did. We had 12 volts. And my power supply actually puts out about 20 amps, I think. I have it also to my 2-meter radio. It's a big power supply, big linear. It's that one I did the video on, the big supply. So we're good. We're good on output. Return to display. Okay, set it for 10 watts. Let's set this for 10 watts. 10 watts. 10 watts. Enter the tune mode long enough to verify that the watt meter is reading approximately 10 watts. If you then switch to voltage current display and hold tune again, you should see a current drain of 1.8 to 2 amps. If you hit the high if you see a high current warning, high current or cal cur to set your to limit it higher. If current is much higher than 2 amps, see troubleshooting. All right, we're looking for nothing much higher than 2 amps on output. We are looking for 10 watts on the tune. So let's see what we get. All right, we are at 2.14. So slightly more, but that's not bad. And we were at 10. I don't know if you saw that. Was that? Well, wait a minute. How do you... I'm not sure how to see the 10 watts while I'm in that thing. Let me just... Oh, I think I got to go to here. Okay. This is where we're going to see the actual wattage out. How many watts we're putting out. Here we go. 8.89, we're putting out 9.2. That's slightly low. Maybe I could peak that up more. Okay, let's do it again by putting it into, wait a minute, that was power. I'm getting confused. All right, display. Okay, there's the voltage and the amps. We'll look at that again. Oh, now it's lower. 12.5 and we're at 1.84. We had 2 before. Okay, and we're putting out how much on power? 11.3. Now that changed. We're putting out more. I wonder why it changed. Let me just check my output. It is set to 10 watts. That's the setting. It's set to put out 10. If we're putting out more than 10, then we're peaked up good. We're going to do tune. We're going to see the power. Putting out 11.3, 11.4. Now we're going to go to the amps and the voltage setting. We got 12.5 on the volts and 2 on the amps. That's good. That's good. I'm not getting a high current warning. It says I should have between 1.8 and 2. It says it shouldn't be much higher than 2 amps. It's close to it. So now I get a lower reading. Well, a little bit. Let's go back here. we're putting out 11 watts. Perfect. Okay, so we're working, we did that. Okay, and I finished that. This completes transmitter alignment and test for 40 meters. So the rest of this, you actually go through more aligning of the bands on receive and more transmit stuff. I don't know if I'll do all this on camera. I basically wanted to capture the fact that it's together now. We're putting out the proper wattage. We're transmitting. It receives. Now I have to finish up the alignment according to the book. I don't know if I don't think I'll videotape all that, but just wanted to show you where I'm at in the build. There's the whole thing. So thanks for watching. 73. Oh, tomorrow I won't be in the shack. I'm going to the Sabres game in Buffalo with my boys. They love the Sabres. I grew up in Buffalo. They grew up in Buffalo until they were younger. Then we moved out toward Albany, and we like to go back for Sabres game. We're going to watch the Sabres beat the Jets, hopefully, in Buffalo at home. There's nothing better than a Sabres game at home. Thanks for watching in 73.